Alright, here we go. I'm not even going to do an intro today, just going to get right into it. Plain and simple, this is a long and iterative process. I have been designing things and redesigning things as I go along. I also have a life. So to get this far from 1 month to the next is a challenge. I have time to work on this project, an hour here, maybe 2 hours there, half an hour there, 15 minutes here. So a lot has happened. Let's go over it. First and foremost, I have been working with a good friend of mine, Crafty Dan Cruz, to come up with a light system. A light system on my own, more or less his design. He helped me know where to solder and what to solder and order what parts. So huge shout out to Dan to help me with that. What you see here is a culmination of a lot of different systems. To start off with that light system, we have embedded in here a small Arduino with a custom PCB that has resistors built in for LEDs. And that's what constitutes the light control system. In addition to that, there are multitudes of wires going throughout. So as I assembled this wing, I had to do additional drilling in the ribs to account for running these wires. And the wires go out both sides for the wingtip lights, as well as the formation lights on the bottom of the wing. In order to also do the landing lights, I have additional wires here that will go in the wheel bays. Next up is the gear door flaps. So the inner gear door, gear door. There are lots of different ways to call these things, but regardless, they have. The doors are very distinctive that cover up the wheels on the Mustang, and the way they operate, for those who don't know, most people do, who are into aviation that is, but they're hydraulically driven on the full-scale airplanes. So when the airplane is turned off, there's no hydraulic pressure. So with that, when the airplane is static, the landing gear doors they sag down because there's no hydraulic pressure. Now when the airplane is powered up, the landing gear doors go up, and when the airplane takes off, the inner gear doors come down, the main gear comes up, and then the doors close again. And then it's the same thing with the landing sequence. Gear doors come down, landing gear comes down, gear doors go back up. So it's a feature that I absolutely had to have on this model because of the look. It completes the dynamic look of the airplane. So to make it as simple and robust as possible, I've taken time to design and integrate my own servo mount within the wing root. And I originally had this idea to use 2 servos, and I wasn't going to mess with a servo reverser. I only wanted to use 1 channel on my receiver because of the number of pins for something else. So I did end up going with a generic servo reverser. I didn't bother trying to take the servo apart. Again, robustness. I didn't want to have a servo that's embedded in the wing fail for any reason for something that I did, so I left it factory stock. I'm using Futaba S3102 servos for those doors and should be plenty strong. They've worked plenty strong on other gear doors that I've used in the past, so I know that it works. I know that it works reliably. I don't want to mess with that. Moving on from there, I'm using the same S3102 servos in the ailerons. And the reason I'm using them in the ailerons is because these servos are a lot thinner. They provide about the same torque as a full-size servo. And on top of that, they're just, I had them on hand. Plain and simple. So that's 4 servos so far in the wings. In addition to that, I am using Spectrum A6180 full-size servos for flaps in the wings, and those were very kindly donated to the project from Horizon Hobby, so thank you much to Horizon Hobby for them. Be sure to check them out. They're a huge supporter of the hobby, and as you guys know, they've been a huge supporter of many of my personal projects in the past, so do check them out. The more they support us, the more we can support them, and the community is better for it all around. All right, so 2 more systems to discuss. Next one is the pneumatic system. So the landing gear that I'm doing on this, if you see my previous video about landing gear conversion and taking older robot retracts and updating them to a slightly different design. So I'm taking those pneumatic retracts, but I have to put in air lines. So I use because of the nature of my job in the biopharmaceutical industry, I know about a lot of different products. 2 of them being tubing and the other one being fittings. The fittings that are typically used in this hobby are not what I would call long-term solutions. They are plastics that would be prone to break down in multiple environmental conditions, whereas the fittings that I would use, the tubing that I would use in my work, they're designed to hold up in a lot of chemical environmental conditions that are very, very harsh. And so because I know where to find them, and I'm not afraid to spend a little bit to purchase them, even though they will be seemingly ridiculous in price. That's why I'm not going to link to them or anything like that, because most people aren't going to use them. But I use these lure fittings, L-U-E-R, and I use a male and a female, one on each end. That way, when I connect them, I don't have to think about what is what. I'll use a corresponding inlet and outlet when I go to do my connection to the air tank system inside the fuselage. But what's nice is you can completely close off the system and make sure no dust or debris gets into it just by having it sealed like this. Now, that tubing also is, it has a very small orifice, and because that doesn't have a whole lot of hold-up volume, and so that's going to help me be able to have an increase in cycles for the given volume of air that I have compressed. So with that, the tubing is run. It's in the wings, ready to accept. And then the last system that we need to go over is the wing connect system. A lot of the feedback and comments and / criticisms, which I didn't even think about would be a criticism on the P47 project, was wiring. People were like, oh, wiring looks horrible. Who cares? Anyway, I've come up with a system, again from Dan. He does this stuff all the time for his job, I might add. So I have this, it's essentially a floppy disk controller connection. However, what's really nice is it has this locker. So as you push in the plug, it locks it into place. And what's really great about that is I don't have to worry about it it keys in. There's only one way to put it in. It's simple, set and forget. It's a ribbon cable, so everything's nice and tidy. Everything's color coded. Everything works. And I plug it in, and it just works every single time. So that's all the systems. Now I need to go over some of the modifications that I've done to the wings so far. So probably first and foremost that I need to make very clear is that I believe that the manufacturer does the very best job that they can, particularly with these top flight models. One area of weakness that I know, and I know that because of other top flight kits that I've built, is the landing gear mounts. Typically there are 2 schools of thought. The one school of thought being you want your landing gear strong enough to hold up in the event of a good landing, but not so strong that they will destroy the wing in some way, that the wing wouldn't be repairable if you had a harsh landing. Given what I've built on my Corsair, I built and overbuilt that landing gear mount to the point where I had, on my maiden flight, if you go back and watch that footage, when I landed, the landing gear towed in and I was down and locked, okay? That landing gear towed in because I was a dummy and didn't do my flat spots with my grub screws, and the airplane nosed forward and just skidded all the way along. Absolutely not a single scratch or crack on the mounts on those landing gear. So I've taken that same school of thought and I've beefed up my mounting rails. I've added an additional 1/4 inch of 5-ply aircraft grade ply, and I've added that with 30-minute epoxy. It's the same width as what's stock recommended. Again, this is kind of a school of thought here. It's sort of a happy medium between really, really strong and it's not going to completely destroy the wing if I have a bad landing. My fear is I have a really horrible flying field to fly from. It's old farmland, and I say this all the time, but it is murder on retracts and landing gear. Okay, it just is. Even carbon fiber stuff on the 3D IMAC airplanes that fly there at our club, people are always breaking landing gear at my club. So this is just insurance for me, because it's just the nature of where I fly. I don't have a paved field. I have access to 1/2 an hour down the road, but you know, this one's less than 15 minutes away. So reasons for that. Next area of modification, as I said, I had to drill these holes in the wing. A lot of people would be really concerned about that, but you shouldn't necessarily. These are the exact same hole locations where the push-pull sleeving would go for the original bell crank design for the ailerons. There would be a single servo here. You can see where my wiring connect is, and that would travel both directions. And I just made those holes larger so that I could fit the roll of wire nice and tidy. Now it is nice because I can also get my servo wires through those same holes. The flap ones I use other stock holes, which are fine, and same with the tubing for the airlines. I had to add some additional holes in the leading edge of the spar here on each one of these ribs, but I just cut those with a razor. I didn't do any drilling. That was after the fact. I wanted those to be as small and compact as possible just to keep things tidy inside that bay. Other than that, I have no other major modifications to the structure. I followed the instructions to the letter. In terms of sheeting, I chose to do the sheeting the way that they recommend. Mostly because it made sense to me with the way that the grain was, the way the assembly was. Once everything's sheeted, I can cut away the flaps, trim those up, and shape everything. So it made sense to me to construct it that way. Now, that being said, I physically glued the wing upside down to my building table. That way I would not have any issues with wing twist. There is a little bit of washout incorporated into this wing design, so I felt it was really important as I sheeted the bottom of the wing to keep that as accurate and as true as possible. I'm going to try to not manipulate or twist the wing too much as I go to sheet the top of the wing, but I have no other way to maintain that square nature of it. So I'm just doing the best that I can, try not to force anything as I do it. But I wanted to cover all of this stuff before I sheet the top of the wing. So as you guys know, over the holiday I took time to do some vacuum pulling in my kitchen with the 3D printed mold. And this is absolutely perfect. It turned out absolutely perfect. This is a primed version of one of those pools, and it's sized very, very well for the mechanism. And what's up next on this is actually some machining work. So in order to connect the spinner to the back plate, I have to drill and tap little tiny holes for screws. I'll do 2 screws here in between each blade. And the reason that I want to do it that way is because, number one, it's light and it's symmetrical, so I'm not going to throw off any balance. But what it also means is I have some additional time on my drill press. Now I have a clamp for my drill press, so I'm going to have to take this whole assembly apart, take the blades off so that everything fits on the work surface properly. I'll clamp it in place and drill it. I have a 1mm drill bit, 1mm drill bit that I will be drilling into each one of these, and I have screws that correspond with a tap as well. Alright, so the last thing that I want to go over on this build that has been kind of a pain that I've been trying to work through is power systems. So those of you who know me and know my builds in the past, I fly off of a Horus, FrSky Horus X10S radio. I love my Horus, and so because I'm on the FrSky system, I do use their receivers. In the past, I've used the X8R servos and the X8R receivers and X6R receivers, and they work great. I've also used them with S-bus decoders, and that works perfectly. So currently I have an RX8R Pro, which I had picked up, if you remember, last summer. I've been fiddling around with gas stuff. Turns out that the one that I got originally, there was a factory defect that I had to send it back for. So I had this, in the end I had this receiver hanging around, and I thought I'll just use it. Works great, there's nothing wrong with it. The problem lies in the decoder. So I tried using a different brand of decoder that I had in the past, and while it works, it only works on the first 8 channels. For some reason, I cannot get this particular decoder to work on any of the channels 9 through 16. So that's been a big problem. So I've been trying to work out some of the programming for the landing gear and flap sequencing, making sure that that's going to work perfectly. I'm sure that it will. It's just a side thing that I've been trying to work through as I have just a few 15 minutes here or there. The other thing that I've been working on is power system. So because of how the pressure sensor, if you go back a video or two, because of how that system works, I need to operate that off of 5 volts. I want to have a little bit more voltage for my servos because I like to have a little bit of extra torque. It's a little bit overkill, but I'll get a little bump in speed on them too. It's a little bit nicer to have a little over 5 volts on some of these larger models in the 60 size range, in my opinion. With that opinion being interjected there, I'm using the FrSky Neuron 8 amp SBEC. I'm going to leave politics out of this, but in order to get the telemetry working and the Lua script working on this BEC, I had to update to the latest firmwares on everything, which meant updating firmware on every receiver I have in my fleet. Major pain, but there we have it. Everything works fine. I haven't had any signal issues. I haven't had any issues at all other than that. There we are. Moving forward, so people know, the Neuron series of ESCs and BEC now, they will have firmware on it that will require you to have the latest firmware on your radio. Something to look forward to. So with that, because of this BEC, I'm able to change the voltage from 5 volts to 6 volts because my servos can operate off of 6 volts. I'm not looking for anything crazy or super strong. I mean, it's a warbird, okay? We're not flying this on the prop, not even remotely. But because I will be running 2, maybe 3 Arduinos, so Arduino base essentially requires 5 volts, okay? The reference for the pressure sensor needs to be at around 5 volts. So in addition to a higher volt system for the servos and receiver, I wanted to have the correct voltage for the Arduino systems. So the Arduino for the pressure sensor and the Arduino for the LED system / systems. It's a little teaser of something to come, maybe. I have put in a separate 5 volt, 3.5 amp BEC. Now, the LEDs and the Arduinos are not going to draw that much current. Okay, we're talking maybe half an amp, maybe. It draws so little current. It's just the correct voltage, and I needed that voltage to be regulated, very well regulated. So that's why I'm doing all of this wiring exercise and making sure everything is going to be perfect, and I have all of the telemetry that I need and want, and I'm going to have RPM sensors and or sensor, and with that will come temperature sensors. So I'll be able to monitor the temperature of my ESC as well, and you know, all of this comes at a lot of complication, but in the end, it gives me a lot of data to set up the model very, very quickly. Again, with the complex prop on this model, I want to be able to set up everything very, very efficiently and reliably, so I know what's going on with the model. I don't want there to be any questions because I want a safe model to fly. Other than that, I have gotten my reference drawings printed out. That was a bit of an ordeal as I had to order ink for my printer and clean the ink head. So I was doing some of that as well. Thankfully, I have a graphic artist for a wife who helped me organize those files and get them done. You know, it's a lot of talking in this update, and that's because I just do not have the time to set up the camera, have a thought of a story that I'm going to tell you, do the work, and then take everything down, and then have time like 2 hours, 3 hours to go and do the post-processing on the video and then upload it for you guys. I just do not have that time right now. I appreciate any understanding. So moving on from there, I have my hands full right now. I'm trying to do multiple different things, not just at home, but at work, and that unfortunately requires more of my hobby time. And while it is unfortunate, I still have high hopes that I'm going to finish this model on time. Okay, we've got all of our tail feathers done. We've got the wing basically done, except for sheeting the top of it, which is like another couple of hours. It's like 2 or 3 hours to do that job. And then from there, I need to put on wingtips and do some shaping. And you know, we're talking another 5 to 10 hours to wrap up the wing entirely. Then we can move on to glass work, and then it'll be ready for assembly. And then I've got the fuselage. The fuselage is partly built already. So again, we're talking about going through some of the problems that may have been just been created by someone else. Having missing parts is certainly part of my process here. Having missing parts in the kit has been kind of an issue. There have been multiple pieces that I've had to create on the wings. Thankfully I have the templates, because the shapes of these parts are not on the plans. And there are measurements that are referenced in the instructions that help me along in some of those things, like where to drill holes. So, you know, keep in mind that because of these various factors, okay, this project is moving at an incredibly slow pace, but I am not willing to compromise on quality here. I'm doing it right, and I'm doing it right the first time, and I think when it's done, we're going to be pretty impressed with how it turns out. So until next time, guys, you know, I look forward to every single video I can put out for you guys. I have another airplane coming from Buddy RC. It's a fun one, and I look forward to sharing that with you guys. I try to get out to the field, but even getting out to the field is more and more difficult right now, just because I do not have the time. But follow me on social media, because I am posting things there that I'm doing. You know, when I do have those 15 minutes here or there, I am snapping pictures, and I am able to take a couple of minutes and upload it and add the hashtags. It's just the video production takes so much time. Anyway, take care of yourselves, and until next time, continue to meticulously build your flying works of art.